Hello, everyone. Today, we're going to cover Chapter 4, Part B. In this part, we're going to focus on how to make a forecast when your data set has a definite trend, an increasing trend, or a decreasing trend. When your data set has a definite trend, we can use the linear regression method. So let's talk about the details of this method. The first question is, why is it called linear regression? Why do we use the word linear? We call it linear regression because we use a linear equation to describe the relationship between x and y. So what are the examples of a linear equation? For example, is y equal to 5.2x squared a linear equation? No. For an equation to be linear, the power of each variable should be 1. Right? What's the power of x? In this case, it's 2. So this is not a linear equation. How about this? Y equals 4. Is this a linear equation? Yes, because y equals 4 means y equals 4 plus 0 times x. And the power of the x variable is 1. And the power of the y variable is 1. So yes, this is a linear equation. How about this? Y equals 3 plus 5x. Is this a linear equation? Yes. The power of x is 1. The power of y is 1. So in general, a linear equation has the following form. Y equals a plus bx. And a is x is the independent variable, y is the dependent variable. A is a constant called the y-intercept, and b is another constant called the slope. Now the next question is, how do we determine x and y? So let's take a couple of examples. Suppose in your data set, you have the daily demand for the electricity and the daily temperature. So for example, when your daily demand is 5 degrees, then the energy usage per household was 32 kilowatt hours. When the daily temperature was 8 degrees, the daily usage was 28, etc. So if your data set looks like this, which one should be X and which one should be Y? Please pause this video and come back with your answer. So let's check the answer. One thing you need to remember is Y depends on X. Does the energy usage depend on the daily temperature? Yes. Does the daily temperature depend on the energy usage? No. So this depends on this. So Y is the energy usage and X is the daily temperature. So let's take another example. Suppose you are working at the HR department of a company and you have a data set that shows the number of years of work experience of each employee and the salary, the annual salary of each employee. Now, which one should be X and which one should be Y? Please pause this video and take a few minutes and come back with your answer. Again, remember, Y depends on X. So does the number of years of work experience depend on the annual salary? No. Does the annual salary depend on the number of years of work experience? Yes. Right? So this is Y and this is X. Now, once you determine X and Y, the next thing you need to determine is A and B. How can you find Y equals AX plus BX? How can you find A and B? There are a couple of ways to do this. The first one is use formulas. The second one is use Excel. We're going to focus on the second approach. If you're interested in the first approach, you can read the textbook and you can go over this example. I'm going to skip this. Now let's see how we can use Excel to find A and B. Let's take this example. The supply chain manager seeks a better way to forecast the demand for door hinges and believes that the demand is related to advertising expenditures. The following are the sales and advertising data for the past 5 months. So in the first month, the sales were 264,000 units, and the advertising expenditure was $2,500. A, find the regression equation. Y equals A plus BX. In this case, which one should be Y and which one should be X? Do the sales depend on the advertising expenditure? Yes, right? So Y equals the sales and X equals the advertising expenditure. Right? This is Y, this is X. To find the regression equation, so let's use Excel. Okay, so this is your Excel. If you go to data and you see data analysis, and if you scroll down, you see regression. Click OK. It says input Y range. So select the Y values, hit enter. Input X range, select the X values, enter. Output range, where do you want your output report? Just click wherever you want your output to be and click OK. Then Excel will generate 3 tables. So where can you find A and B? So in the third table, you'll see something called the intercept. This is A. And you'll see something called X variable. This is B. Okay, so here you can find A and B. And let's look at the first table. In the first table, you'll see something called R squared value, which is 0.9595. So we'll talk about this a little later. So this is how you find A and B using Excel. Okay, so let's go back to the slides. So the next question is, the company will spend $1,750 next month on advertising for the product. Use linear regression to forecast sales for the next month. So we already have the regression equation. This was A, this was B. And the question says the advertising expenditure for next month will be 1,750. So should we just plug it into X? Remember, X is expressed in terms in thousands of dollars. So we actually in 1,750 in the X value will be 1.75. Okay? So we need to plug in 1.75 and then compute this equation. You get 183.016. How can we interpret this? Again, Y is also expressed in terms of thousands of units. So you can interpret this as 183.016 thousand units. Now, so So far, we talked about how to find A and B using Excel. And the question is, which line are we computing in Excel, or if you're using formulas, either way, which line are we computing? So here's what Excel finds. First, Excel plots the data points in the XY plane. So these are the data points. And then Excel finds the straight line that's the closest to the data points. And the equation of this closest line will be the regression equation. But what do we mean by the closest line? How can you even measure the closeness between a line and data points? So let's take a very simple example. Let's compare these two lines. Which one is closer to the data points? This one or this one? Obviously, the first one is closer. By looking at the graph, you can get a sense of which one is closer. But mathematically or specifically, how can we measure the closeness between the data points and a straight line? So we're gonna, here's how we measure the closeness between a line and data points. We're gonna start from the first data point, and then we're gonna measure the distance between this point and the line, which is this line, which is the length of this line segment. And then we're gonna square it. And then we're gonna go to the second data point, measure the distance between the second data point and the line, and square it. Square this distance, and you're going to repeat this for the rest of the data points. Measure the distance, square it, measure the distance, square it, square it, square it. And then we're going to add them up. And that's called the sum of squared errors. And this measures the distance between the data points and a straight line. So, and the smaller the sum of squared errors is, the closer the line is to the data points. So to find the regression line, we're going to compute the sum of squared errors for every possible line on the XY plane. And then we're going to choose a line that has the smallest sum of squared errors. So the one with the least sum of squared errors is called the linear regression equation that Excel returns. So the linear regression method finds the line minimizing the sum of squared errors. So it's also called the least squares method. Now, I want to make a couple of comments. The first one is something about the R-squared value. The R-squared value is also called the coefficient of determination. So when we ran Excel, Excel reported the R-squared value in the first table. So what's the meaning of this number? It tells you how well the regression line fits the data points. So you can think of this as the percentage of data points that are explained by the regression line. For example, let's take this case. All the data points are on the regression line. What percentage of data points are explained by the regression line? 100%. So R-squared value is 100, 1. And let's take this example. The data points are not on the regression line, but they are close to the regression line. Then we can say that 80%, about probably 80% of the data points are explained by the regression line. So R-squared is 0.8. And let's look at this example. The data points are all over the place. What percentage of data points are explained by the regression line? 0. So the R-squared value is 0. In fact, we are using a very specific formula for R squared value, but I'm explaining how, the meaning of the R squared value. How can we interpret this? So this one, again, the data points are not on the regression line, but they are close. So in that case, R squared turned out to be 0.8. And in that case, all the data points are on the regression line. So 100% of the data points are explained by the regression equation. So the R squared value is 1. So the R squared value is always a positive number between 0 and 1, indicating X and Y have a linear relationship or not. And the higher R squared is, the stronger the evidence is. And R squared is called the coefficient of determination, and R, which is the square root of R squared, is the coefficient of correlation. Now, the next comment I want to make is multiple regression analysis. So far, we talked about simple regression method, where we have only one X variable. Y depends on only one factor. But in many cases, Y depends on many factors. If that's the case, we'll need to use more than one X variable, more than one independent variable. So for example, if Y depends on 2 factors, we can use a multiple linear regression model, and Y equals A plus B1 times X1 plus B2 times X2. B1 and B2 are 2 independent variables, and then A and B1 and B2 are constants. So this is called the multiple linear regression method. So when should you use the multiple linear regression method? Let's take an example. Let's say you want to predict the average home price in Long Island, and the average home price depends on many factors. What factors will affect the average home price? The mortgage rates, how many people want to buy homes, and the average income level. So if that, in this case, we need to use multiple regression equation with 3 independent variables. So the home price Y equals the intercept, B1 times X1, which is the mortgage rate, plus B2 times X2, which is the population, plus B3 times X3, which is, X3 is the income level. So this is everything we have in this part. I'll see you next time.